You hear about averages all the time, right? The average salary, the average test score, you name it. But today, we're going to see how that one little number can sometimes lie to you. And we're going to discover the simple tools that show you the real story hiding in the data. Okay, let's kick things off with a scenario you've probably seen before. A student gets an 85% average on their exams. I mean, on the surface, that sounds pretty solid, yeah? A good, solid B. But is that number really telling us the whole story about how they're doing? And this is where it gets really interesting. So check this out. Look at student A. Their scores are super consistent, always hovering right around that 85% mark. Pretty steady. But now look at student B. They have the exact same average, but their scores are all over the map. We're talking some high highs and some really low lows. That 85% average completely, totally hides this massive difference. And that is the big idea here. The average, or the mean if you want to get technical, it's great at telling us the center of our data. But it tells us absolutely nothing about how spread out or dispersed all the data points are around that center. So how do we actually measure that spread? Well, that's where these awesome statistical tools come in. They're called Measures of Dispersion, and they're what let us look past that simple average and really understand the variation happening inside our data. All right, let's dive in with the easiest, most straightforward one of them all, the range. You're not going to believe how simple this is. You literally just find the highest value in your data set, find the lowest value, and subtract the low one from the high one. And boom, that's it. That's the range. So for instance, in a class of 20 students, if the top score was a 98 and the lowest was a 58, the range is just 98 minus 58, which is 40. Easy enough, right? It gives you a really quick snapshot of the total spread. Ah, but there's always a catch, isn't there? See, because the range only cares about the two most extreme points, the absolute top and the absolute bottom, it can be incredibly misleading. So what happens if one of those points is a huge, weird outlier? And this slide, wow, this shows you exactly what I mean. We've got incomes for 10 people here. Most of them are making, a pretty typical salary, somewhere between 30 and 60 grand. But then you've got person J, and they're making $2.5 million. That one person's income completely blows up how we see the data spread. And this is what the source material just nails. That one single outlier creates this massive range of almost $2.5 million. That tells us nothing useful about the spread for the other 9 people, right? In statistics, we'd say the range isn't robust. One weird number can totally break it. So what do? We need a tool that can basically just ignore those crazy outliers and give us a more honest look at the typical spread. And for that, let's bring in the interquartile range, or the IQR. Now, the IQR is super clever about this. Instead of looking at everything, it just lops off the bottom 25% and the top 25% of the data. It focuses only on the middle 50%, and then it calculates the range of that chunk. Pretty smart. And figuring it out is actually pretty easy. Here's how it works. First, you line up all your numbers, smallest to biggest. Step 2, find the one smack in the middle. That's your median. Now for the quartiles, you just find the median of the lower half of the data, that's called Q1, and you find the median of the upper half, that's Q3. The IQR is just Q3 minus Q1. That's it. So let's go back to those incomes. Look at this difference. It's just wild. The range, which got totally wrecked by that one outlier, is almost $2.5 million. But the IQR, by focusing on the middle of the pack, gives us a spread of just $34,000. I mean, come on, which number do you think gives you a better feel for this group? It's the IQR for sure. Okay, the IQR is great for ignoring outliers. But what if you want a measure that actually uses every single piece of data you have? For that, we need to turn to the real heavy hitters, the most common and powerful measures of spread: variance and standard deviation. So what the heck is standard deviation? Well, think of it like this. It's one number that tells you the typical distance that every data point is from the average. So a small standard deviation means all your data is clustered really tightly together. A big one means everything's much more spread out. Okay, but wait a second. How do you find one single typical distance? I mean, some points are above the average, some are below it. If you just try to average out those differences, all the positives and negatives would just cancel each other out and you'd get 0, right? Well, statisticians came up with this really smart 4-step process. First, you find the mean. Easy. Step 2, And this is the key move. You measure how far every single data point is from that mean, and then you square that distance. Why? Because squaring makes every number positive. Step 3, you take the average of all those squared distances. And that number has a special name. It's the variance. And for the final step, you just take the square root of that variance, and you've got your standard deviation. So what's the deal with these two? Here's the most important thing to remember. The variance is a key part of the math, but its units are kind of weird, like dollars squared. Who thinks like that? The standard deviation just takes the square root to bring it all back to the original units, like regular dollars or points on a test, which is just way easier to wrap your head around. Okay, phew. We have gone through a bunch of tools. So, how do you know which one to use? Well, the best way to think about it is like a toolkit, right? You got to pick the right tool for the right job. This slide really just puts it all together for you. So here's the bottom line. If you need a super quick snapshot and you're pretty confident you don't have any wild outliers, the range is fine. If you do suspect there are outliers, the IQR is your best friend. It gives you a much more honest look at that middle ground. And for the most robust, detailed picture that actually uses every single data point, you're going to want to use the standard deviation. So from now on, the next time you see an average in the news or in a report, don't just take it at face value. Now you know the single most important question you need to ask to get the real story. You can just ask, okay, but what's the spread?